If everyone could please make sure that their microphones are muted so we do not receive feedback from other people's background noises, that would be great. Once again, my name is Carolyn Ayler, and I'm the Watershed Outreach Coordinator for the Jasper County Soil and Water Conservation District. So today, thank you for joining us for our virtual septic maintenance workshop. Today we have 6 staff members and presenters that will be bringing different information about proper septic maintenance and how it also relates to the Lower Kankakee Watershed Initiative project. So thank you once again for joining us, and we have a lot of information that is going to be coming within the next hour. Okay, the Lower Kankakee Watershed Initiative. So you can see here our mission, who we are, and our funding source. So it is a 3-year grant from the Indiana Department of Environmental Management for almost $200,000. What we are using these funds for is to write a watershed management plan for the sections of the Lower Kankakee River that go through Jasper County and part of Newton County. Currently, we are at section 20 of the watershed management plan in the writing process. We have many great partners for this project, and we couldn't do it without all of these partners. So we thank them for being involved and helping with this great project. Here is a map of our watershed. You'll see the area is quite large, and it encompasses several of the large towns in Jasper and Newton County. Now, the land use in this watershed is 80% agricultural land, which I don't think is a surprise to most people. And it comprises 291 square miles. So like I said, it's a very large area. The water quality in this area, E. coli exceeds state limits, and it is listed on the 303D list of impairments. Also, according to the EPA, this region is in the top 25% of contributors to the zone of hypoxia in the Gulf of Mexico. We also have a historic water quality data, and they are also collecting more water quality data every month through this grant process. So we have started a steering committee, and they guide our efforts in writing the watershed management plan. If you'd like to join our efforts, please reach out to us. You can call us, or you can log on to our website, kankakeewatershed.org, and you can contact us that way as well. Okay, if everybody could please take either their smartphone or open a new browser, we're going to go to Slido and take a quick survey. We'll be doing a pre-survey and a post-survey. This is completely anonymous, and this will just tell us how effective this workshop was in making sure that everybody was to gain the knowledge that we were hoping they would gain. So if everybody could please log on to Slido. All you do is the code is LKWI for Lower Kankakee Watershed Initiative, and there are 5 simple questions that you can fill out there. So next up, you're going to be hearing more from Bree from the Newton SWCD, and she's going to talk to us about how septic maintenance issues actually tie into the Lower Kankakee Watershed Initiative project.
So as Carolyn said, I'm Bree here with the Newton County Soil and Water Conservation District. I started here in February, and before this I was doing all kinds of septic stuff up north, and I'm really excited to talk to you guys today. So why are we here, and why in the heck do we care about septic systems? As Carolyn had already explained, this is part of our Lower Kankakee Watershed Initiative. So a watershed is all of the land in an area that water from rain and snowmelt flows across and through until it gets to a central point, like the Kankakee River. So as the water is flowing across the land, it's picking up all sorts of things, whether it be pollutants or nutrients and soil and oils and stuff like that. And it delivers it directly to our waterways and eventually our homes. I don't know what that is. Okay. As part of this effort, we're looking at several measures of water quality, both biotic in the living creatures and abiotic in the chemical and physical parameters, to help us identify where some problems are throughout the watershed. So from there, we'll design future projects and direct conservation work to alleviate these problems and improve our water quality. E. coli is one of the parameters we're looking at. So we're looking at E. coli. E. coli is a bacteria that can cause serious illness if ingested by humans. So if you think about our Indiana beaches, there are several days throughout the year that the beaches are closed due to the high E. coli bacteria level. You don't want to swim or drink the water or anything like that. Possible sources of E. coli are human, geese, remnants, dogs, things like that. So animals and agriculture can contribute to E. coli through fecal matter and manure applications. Humans can contribute E. coli primarily through failing septic systems. So if you think about your toilet, the solid and liquid waste flow out of your toilet into a big settling tank. So once they're here, all the solids will settle out and the liquids will come to the top. And that's what ends up flowing out through your drainage field. So as that water then is percolating through the ground, all the soil microbes can treat that bacteria before it hits our water supply. So septic tanks are only designed to hold so much solids. And when the solids become too much, both solid and liquid then flow through that drainage field and it can get clogged up and you get a whole big mess, just like in this picture here. So if it doesn't go out normally, it can back up into your house. And all of that raw sewage then goes directly to our ground and surface waters. Last February 2019, Porter County Soil and Water Conservation District partnered with the United States Geological Survey, and they just wrapped up a study that identified the main cause of E. coli flowing into the Lake Michigan watershed was actually from humans through failing septic systems, as opposed to agriculture like many people thought. There's another study being conducted in all Lake, LaPorte, and Porter County right now that's confirming the exact same thing. A 2005 report from Purdue University estimates that 1/4 of all septic systems throughout the entire state, so that's around 200,000 septic systems around the whole state, are failing at this moment. So if we bring that to the number of people on the webinar, what do we have, like 15 or 16? So say we have 16 people on the webinar right now. Take 1/4 of that, that's, let's see, 6,650. That ends up being 300,600 gallons of raw effluent that could be potentially flowing out of the septic systems just on the people from this webinar right now. So each septic system that's failing releases 76,650 gallons of raw effluent every single year directly to groundwater and surface water. So if that's 4 people on this webinar, that's quite likely your septic systems might be having problems and not operating properly. That is a lot of raw sewage just right now that could be potentially leaching into yours and your neighbors' groundwater and well water. So if you're on septic, chances are you likely have well water as well. So those wells are designed to pull water up directly from the groundwater supply and then into your home. So if your system is failing and you have all that raw sewage effluent going directly down into that water supply, it's very possible you could be contaminating your own and your neighbor's drinking water. So we're here today to help you prevent your septic from failing in order to save you money, keep you healthy, and try to keep our waters clean. So with that, thank you guys again so much for being here today. And I'm going to pass it off to Lana, who's going to cover where our biggest E. coli issues are.
All right, very good. So as I mentioned to you, I've been involved with the district for nearly 20 years now. And so I've had an opportunity over time to participate in a lot of excellent water quality related projects. And one in particular that we started was in 2007. All right, so just to see where you are, here's Sweetfield, DeMott. You'll notice that these sites are labeled. J is simply referring to Jasper County, and the N is referring to Newton County. We have 20 sites that we are currently testing. Derek has been testing about once a month, give or take, due to the grant and various other situations. We have about 2 more months of data that we're going to be collecting. So again, I'll give you a moment to sort of locate yourself and see where some of these sites are. Specifically, the sites are on bridges. They collect just upstream from a roadway off the bridge. And there are that set of tests that Bree mentioned earlier. We do test for many different parameters, but for purposes of today, we'll just be talking about E. coli. Okay. Secondly, I want to share you now share with you the data. And those with the asterisk beside them, we have water quality data from 2007 for comparison. The data that you see on the right, you'll notice those are by month. And the testing unit is referred to as most probable number. The subwatersheds, if you look back at the map on the right side of your screen, there's actually 12 subwatersheds within the 3 watersheds that were delineated in the earlier map. These are called HUC 12 level, which just refers to a size. You might recognize the name of some of those ditches in those subwatersheds. The data then, what you see in pink is illustrating that number exceeds safe body contact. I mentioned a most probable number. That is 235 is the highest limit for safe body contact. Now, if it's drinking water, of course, the E. coli numbers need to be 0. So we're just talking specifically about surface water that might be, you might swim in, walk through, get on your hands. So we're looking for numbers below 235. Everything that's in pink exceeds that number. You might also notice that the data really jumps around, like on J6, for example. In January, that number was 2,419, as compared to the following month at 35. So know that when these samples are collected, it is literally a snapshot in time. So there could be a release of some kind into that stream, and on that day, on that moment, E. coli count was extremely high. So what we're looking for are probably consistent high numbers that would really indicate, a big problem. The other thing to consider, Bree mentioned earlier, is that we have a lot of livestock manure that's spread in our fields at various times of the year. So if you look at the May data, you'll see that 2 of the Newton County sites are very high. More than likely that came from animal manure being spread. Looking back at the 2007 data, that's in the second column, I've highlighted the colors to indicate improvements, some high, some low. So the yellow number just indicates that it's kind of in the middle. If you look across that row, you'll see that some of the numbers are much lower, and you'll see a couple of numbers that are higher. In green, those are highlighted to show we now have a significant reduction at that site from what we saw in 2007. And then N14, which is in pink, with a number of 126, which is still within safe limits. It was lower previous to what it is right now. And you'll see that in May, that number was 866 as the most probable number. So with this collection of data, then, we're able to make a case for seeking other grant funds for developing other water quality related projects as we move forward. All right, that's all I have.
Lana, thank you so much. Now we'll be moving over to Alice Quinn for the main part of our presentation.
I'm so glad to be here. I've got lots of slides to go through and very little time, so therefore I speak very quickly. If you don't understand something I say, there's going to be contact information at the end of the slideshow, and you can feel free to contact me at any time. So as I said, I am the Senior Environmental Manager of the Residential Onsite Sewage Program here at the Indiana State Department of Health. I like to start off with a quote. Most people don't understand that public health does deal with sewage disposal. This is a quote from George E. Waring Jr., who was a an engineer as well as a war veteran, and instituted the practice of cleaning up the streets in New York City to promote public health, and greatly reduced the rate of death and the filth that was in the city. It has hitherto been, and in fact it still is, the practice of the world to consider its waste satisfactorily disposed of when they are hidden from sight. Well, out of sight, out of mind is what they usually say. And unfortunately, in the world of wastewater disposal, that's not always the case, because just because it's out of sight doesn't mean that it cannot affect our public health. As Bree showed you, or stated, that just the discharge of that effluent goes to our waterways, and it can contaminate our public and private drinking water supplies. So in order to understand the ramifications of a failing on-site sewage system, we first have to understand what an on-site sewage system is. The State Department of Health has two rules, and they're shown here on the slide. One's for residential on-site sewage system, and the other's for commercial on-site sewage systems. They mimic each other greatly, but they're just a little bit different. We're going to focus today on that residential on-site sewage system. This is just a brief slide to show you that regulations in Indiana, as far as sewage disposal goes, are not a new thing. Clear back in 1930, the state of Indiana had requirements for sewage disposal from the private individual home. So it's not a new thing. Our newest rule was originally passed in 2012 with some updates in 2014. But this just shows you that, people want to reference grandfathering of sewage disposal, and really, we don't have any grandfathering of sewage disposal. A health hazard cannot be grandfathered, and we have had those rules in place for many, many years. So what is sewage? We actually define sewage as all wastewater carried and derived from normal, ordinary living processes. That includes toilet water, bathing and shower water, laundry water, food prep and dishwasher water, and water softener backwash water. You notice in Indiana, we do not separate out gray water from black water. Typically, black water is considered toilet water, and that's what's seen as the really bad wastewater. But quite honestly, all of that type of water in Indiana is considered sewage, because it all carries pathogens, it all carries nutrients and chemicals, and we have to properly treat and dispose of all of that water. And for some reason, there we go. It was stuck there for a minute. Those sources of clean water or groundwater, we do not consider sewage, and they cannot go to the on-site sewage system. So discharges from sump pumps, foundation drains, swimming pools and hot tubs and floor drains do not go to the on-site sewage system. Our systems are not sized to handle that amount of water from those sources. And quite honestly, those sources should not be pathogen-laden and chemical-laden waters. So sewage treatment, there's a few options that folks can be connected to for sewage treatment, and in many cases, homeowners often aren't aware of what option they have at their home as far as sewage treatment. The first one, and probably the best known, is the municipal sewer system, or the sanitary sewer. It's also sometimes referred to as centralized system, or the big pipe. This is where many homes and businesses are connected to a large pipe that delivers the wastewater to a municipal plant for treatment. The second one is not well known. It's a cluster system, or a decentralized cluster system, where a group of homes or homes and businesses can be put together on a single very large septic system. So while we don't see many of these in Indiana, we do have some small cluster systems serving some groups of homes. It's difficult because all of those homes have to belong to a homeowners association, or have some sort of community support to finance that system, as well as to maintain the system. And what we're here to talk about today is that private on-site sewage system, also called a septic system, or just a decentralized system. You'll hear that sometimes. So that is just to serve a private residence or just a single commercial facility. So where are on-site sewage systems used? They're commonly used in rural areas without centralized sewer systems, those folks that are beyond the reaches of the central sewer. And it's an underground wastewater treatment structures that combines nature and time-tested technology to treat the wastewater produced from a single residence or commercial facility. This is based on the 2010 census. It shows residential and commercial installations at the time. We're talking about the numbers of systems, types of systems, new and repair permits. So you can see the map shows the density. So the darker the color, the more dense our septic systems are, or the more homes that are outside those reaches of sanitary sewer and rely on private systems. Our rule, that Rule 410, also defines what an on-site sewage system is. It's all components and devices necessary for proper conduction, collection, storage, treatment, and on-site sewage disposal from a 1 or 2 family dwelling, a residential outbuilding, or 2 single-family dwellings on the same property with less than or equal to 5 bedrooms. It includes, but is not limited to, sewers, tanks, soil absorption systems, holding tanks, and sanitary vault privies. And we'll go over what some of those things are shortly. Our rule goes on to say that any dwelling that is not connected or cannot be connected to a sanitary sewerage system, so that big pipe, if the home cannot be connected to that system, it has to be provided with a residential on-site sewage system that includes both a septic tank and a soil absorption field that has not failed. Now those red underlined words become very, very critical in our next few slides as we go through what that exactly means. So our rule requires that we have a septic tank and a soil absorption field that has not failed. The septic tank here is shown in dark gray. It usually sits about 10 foot outside the house. And then we have a soil absorption field that I've shown here just as a green box, because that soil absorption field, we have many different technologies and many different configurations as to how that soil absorption field can be installed at the property. We also have to have a means of conveyance. So while we have to have a septic tank and a soil absorption field, we also have to have pipes that connect those systems or those components so that the sewage can make it from one to the other. So we have a residential sewer. We also have an effluent sewer. The residential sewer goes from the house to the septic tank and has to be at least 10 feet in length, because we have to have that septic tank setting at least 10 feet from our house. That is the only pipe in the entire system that carries both liquids and solids. So that's a big deal, because we have to have a required slope on that pipe so that we don't separate out those solids from the liquids and have a plug in that line. Typically, if there's a plug in a line, that's where it's going to be, in that residential sewer line. The effluent sewer carries the liquid portion out of the septic tank onto the next component in the system. Now, we typically think of our soil absorption field as trenches. This has kind of been a conventional system in the state of Indiana for many, many years. So here I've labeled the soil absorption trenches as well as a distribution box. When we distribute effluent to these soil absorption trenches, we have to split that flow equally so that all of those trenches do an appropriate amount of work for that system. We can also add components such as a dosing tank and an effluent force main. This dosing tank will have a pump in it, and it puts the effluent under pressure. It pumps the effluent to that distribution box in this particular system. We can have subsurface drainage. Many of the systems installed in the state of Indiana have to have subsurface drainage so that we can provide an aerobic zone or an oxygenated zone under that soil absorption field for proper treatment of all those pathogens that are carried in our wastewater. And then we also, a lot of times, we'll see surface diversions. So in our landscape, when we go from a higher landscape to a lower landscape, if that septic system or the soil absorption field is downslope, receiving surface water flow, we need to divert that surface water around the system so that that system can just focus on the water that's coming from the home and not have that additional hydraulic component from surface water at the site. So for now, we're going to consider our soil absorption field just to be a box. It's just that green box there because there's so many different types of soil absorption fields. I don't want to specifically rely on any one particular system at this point in time. So a septic tank, that's our primary component. Remember the septic tank and the soil absorption field. So what does the septic tank do? It receives all the water carried waste from the house. So everything from your showers, your toilets, your kitchen sinks, your washing machine, your water softener, all of that discharges to the septic tank. It provides the primary treatment of the wastewater. So in your septic tank, this one down here at the bottom is what we call a single compartment septic tank, and that is very common in the state of Indiana. The wastewater comes in from the house, hits a sanitary T or a baffle here, and the solids fall to the bottom of the tank and become sludge. The fats, oils, and greases, everything that's lighter than water, will move to the top of the tank and become scum. The middle portion here, the lighter yellow, is called effluent. That is the liquid portion of the wastewater. The liquid portion of the wastewater moves through an outlet filter, and it's more like a screen. It screens the water that's going out the outlet of the septic tank into the soil absorption field to make it cleaner. So we're removing a lot of that organic material before it leaves the tank. Here we see in the top left, we see a 2-compartment tank. These are becoming more and more popular in Indiana, and they actually do a significant amount of work in bettering that effluent quality before it leaves the septic tank. So we have our primary chamber here, which is the largest chamber. It collects most of the sludge and the scum with flow through the baffle there into the second chamber where we allow additional settling and further clarification of that effluent portion before it goes up and out through the outlet filter. So the primary purpose of the septic tank is separation of sludge, effluent, and scum. And it's simply done as a matter of weight. Those heavy things that don't dissolve in water are going to float to the bottom and become sludge. The fats, oils, and greases, which are lighter than water, physically separate from the wastewater and become the scum. The design of the tank is meant so that that clear portion in the center of the tank, the cleanest of the wastewater, is what actually goes out to the soil absorption field. Okay. Outlet filters are something that have been required in all new septic tanks since 2011. This is one type of outlet filter here. It is not in a cartridge in this picture. It would normally be in a cartridge. So if your septic tank was installed prior to 2011, it's really unlikely that you're going to have that effluent filter in your tank. These effluent filters in the state of Indiana are required to filter down to 1/8 of an inch. And these cartridges are removable for cleaning. So when this cartridge starts to build up with stuff that's been filtered out of our wastewater, we'll have to pump the septic tank down and clean that outlet filter so that the tank can continue working. A plugged outlet filter is absolutely doing its job. It's capturing all of those small particles so that they don't go out into the soil absorption field and cause problems out there with plugging of holes in piping or plugging soil pores. So the soil absorption field, like I said, can consist of many different types of technologies. Our definition of soil absorption field is pipes or chambers laid in a system of subsurface trenches or pipes laid in elevated beds into which the effluent from the septic tank is discharged into the soil for treatment and dispersal. Now, I like to comment on that treatment and dispersal. Those are both very, very important aspects of our soil absorption field. And without both of those actions happening, our system is going to fail. And we'll talk more about those in a bit. So we have 5 different types of conventional soil absorption fields that are allowed in the Indiana rules. The first is the gravity-fed system, been around for a number of years. It is the system of choice by the Indiana homeowner because it is the simplest. It's going to be the least costly to install. Essentially, we have a house served by a septic tank, Everything flows by gravity. That effluent goes out through the soil absorption field to be treated and dispersed in the soil. The second conventional type of technology is called gravity flow alternating fields. It's essentially the same as your basic gravity system, but we have two fully sized soil absorption fields with a diverter valve in the middle. So we can rest one field while the other one is working. And then each year that diverter valve is twisted so that the other field is then used for a year. So that allows our fields to be rested for a period of time. The third conventional type of system is described in our rule as a flood dose system. Again, it has the same basic premise as our gravity flow system, but we've added that component there, the dosing tank. There's a number of reasons why we add dosing tanks to systems. The most obvious reason is if we have to go up in elevation. Sewage does not flow uphill, so sometimes we need that pump to give it the boost it needs to get up to the soil absorption field. Other reasons why we put a dosing tank in is if our soil absorption field gets too large. Anything over 500 linear feet requires dosing, simply because we don't feel that gravity flow is going to adequately disperse that soil or that effluent through the entire soil absorption field. Also, if we're dealing with some shallower soil, we can overcome that limitation sometimes by the addition of a dosing tank. Subsurface pressure distribution also has subsurface trenches as shown here. It has a septic tank and a dosing tank with a pump in it. It does not utilize a distribution box. It uses a pressure manifold. So in this system, that pump will pressurize effluent clear to the ends of our laterals. This is not a real common system in the state of Indiana, but we kind of feel like it's the Cadillac of our conventional systems, simply because the homeowner gets their wish for an in-ground subsurface system, but we also get the benefit of distributing the effluent throughout the entire soil absorption field from day one, because we're pressurizing and making sure that effluent gets to the very ends of those distribution laterals. The last kind of conventional system discussed in our Indiana rules is the elevated sand mound. Again, we have our septic tank and a dosing tank, and this elevated sand mound is built from the ground surface up. It also is a pressure distribution system where we have an effluent force main coming from the dosing tank, and this is our distribution network, and effluent is spread out over that entire aggregate bed by pressure, somewhat similar to the subsurface trench system, only it's an elevated system. In recent years, we have approved sand line systems in the state of Indiana. Many of you might recognize the terminology, the Presby system, or the Infiltrator HEL, or the Elgin GSF system. And that's what we're referring to when I say sand line systems. These are typically constructed in beds, so they're very unlike our other technologies as described in our rule. We have subsurface beds. We can also have elevated beds. And a lot of times these systems will use what we call serial distribution, where there's a network of piping in a bed of sand. So we utilize one pipe until it overflows to the second pipe and then again to the third pipe. And there's any number of pipes that can be used. This is just one configuration. So if you hear sand line systems or any of those manufacturers, know that we have approved those for general use in the state of Indiana under guidelines and requirements set out by the manufacturers. So if our soil absorption field, like I said earlier in the definition, soil absorption field has to treat the effluent, it also has to move the water or disperse the water. If we don't treat the effluent, but we move the water, we're just moving that source of contamination. Bree talked earlier about how that effluent can travel both to our open water sources as well as our wells. So if we're moving water, but we're not treating it first, again, we're just relocating that source of contamination. If we treat the effluent, but we can't move the water away from the system, then we've also got a problem. That system's going to work for a period of time until it gets full. It's like a bathtub with a stopper in the drain. So if we can't move the water, the bathtub gets full, And when the bathtub starts overflowing, then we're no longer treating the effluent. So both of those situations are going to result in a failing on-site sewage system. And that's why we include that in our definition, because the soil absorption field has to do both of those things. It has to both treat the effluent and move the clean water away from the system so that it has more room to accept that wastewater from the home. We also have a definition of failure in our rule, and it's an on-site sewage system that exhibits one of the following: interference with home, such as a backup in the home. You see the lovely bathtub there that's had a backup of sewage in it. Most homeowners really don't care for that type of failure and will get really quickly on that to repair or replace that system. The second thing, it could exhibit ponding, seepage, or discharge to the ground surface or surface waters. Now, this is the common type of failure that most people think of. And it's the kind where you make the complaint on your neighbor because he's got a stinky pile of sewage in his backyard, or it's discharging into the creek, or something along those lines. So that's the most common thing that people think of when they think of a failing septic system. The third is a discharge that causes contamination of potable ground or surface waters. So again, it can be any of those waters. And in that middle image there, we see some greenish colored water coming through somebody's kitchen sink. This happened when a septic system was dye tested, and within a day, the folks were bringing up their own sewage water, untreated sewage water, through their private drinking water well into their kitchen sink. So that's the ultimate in recycling, not really the type of recycling we like to see. That definition goes on to tell us that a failure is a health hazard, and that's why we're here today. That's what we're concerned about. A failure is a health hazard, and it can cause a health hazard for not only the occupants of the home, for anyone that shares drinking water from that same aquifer, anyone that comes in contact with that sewage, wherever it's discharging. Also, the rule says that no person shall throw, run, drain, seep, or otherwise dispose into any of the surface waters or groundwaters of this state, or cause, permit, or suffer to be thrown, run, drained, allowed to seep, or otherwise dispose into any such waters, any organic or inorganic matter from a dwelling or residential on-site sewage system that would cause or contribute to a health hazard or water pollution. So again, we're preventing both health hazards and water pollution. Public health aspects. Sewage or diseases from sewage are a public health hazard. In Indiana code, a person shall not institute, permit, or maintain any conditions that may transmit, generate, or promote disease. That's a statute that's often referenced by local health departments in enforcement activity when they have discovered someone with a failing on-site sewage system. We deal with rules a lot, the Indiana administrative codes, but this is an actual statute, Indiana Code 16-20-1-25A. So it's often referenced in those abatement orders. So why should I care? Why should you care? This is kind of my soapbox slide, and I really enjoy this slide because this is why I do what I do. And this is why I hope you really take this to heart. First off, we're protecting our future generations. It's not just us living in this world that we need to worry about. Hopefully some of you have kids or grandkids or great-grandkids, and we have to realize that whatever we do to the waters here on Earth, we're passing down to those future generations. And if we don't take care of our resources, they're going to have to take care of those for us. The second is the home is typically the largest investment that people are going to make in their home. I know certainly that's true for me. We spend a lot of money on our home, and we want a nice place to live, for our lifetime. So why put that much money into your investment just to have a septic system that is failing or causes a public health hazard or contributes to water pollution? The third reason I do what I do is because we have to protect our drinking water sources. We don't make new water. We're given the water that we've got, and we have to keep it as a resource. So we have to protect those resources. Fourthly, we have to also realize that we're not the only species that inhabits the earth. Those natural waterways, natural beauty of our environment are shared by both other people as well as wildlife and our pets. And we have to properly maintain those for others that join us on this earth. The water recycle, I know Bree hit on this briefly. So again, we don't make water, we have to recycle the water that we have here. And once it's contaminated, it's really hard to get it cleaned up. Again, those septic systems utilize that natural soil and natural scientific processes to do that work for us, and they do a very good job of it. 25% of the U.S. population depends upon on-site sewage disposal. So 25% of all the people in the United States do not have connection to a sanitary sewer. That number goes up to about 34% of Hoosiers. We're a very rural state, and we have a lot of folks that rely on on-site wastewater disposal and private septic systems. When I think of the counties with the large municipalities like Indianapolis, Fort Wayne, Gary, those counties still have a lot of people that are on on-site sewage disposal systems rather than connected to sanitary sewer. So public health aspects, these are just major diseases that are associated with sewage. I know Bree talked to and Lana talked to both about E. coli. E. coli is just one type of bacteria. And while there are some strains of bacteria or of E. coli that are very, very detrimental to health, please understand that E. coli is really only used as an indicator organism. It's very easy and very cheap to test for. So we test for blood levels of E. coli, and when those levels get to a significant point where we think that that's going to be a health hazard, and that's that 235 number that Lana was talking about, we have a kind of a guilt by association when the E. coli level gets high, and we presume that to mean that that body of water has been contaminated by a fecal source. We also have to understand that there's many other bacteria, viruses, protozoa, all kinds of pathogenic organisms. And we have viruses listed here: hepatitis A, polio, gastroenteritis. And I hate to bring this up, but I'm here to tell you that COVID-19 is a virus. There are studies going on right now to determine if that can be transmitted through sewage. So in a year or two, when the jury gets back on that, whether that can be transmitted through sewage, we may have to add COVID-19 to that list. And I hate to bring that up because that's something on everybody's mind right now, but this is the impact that we could have. A lot of these diseases, I'm sure some people have never heard of, never experienced, but I'm here to tell you that they're real possibilities from contamination with sewage. Also, discharging areas of sewage provide prime breeding areas for mosquitoes that carry diseases: St. Louis encephalitis, West Nile virus, Zika virus. We can add to that list now because there's a lot more out there, and it just seems to grow every year. We have some soil absorption technologies that were utilized in the past that are kind of antiquated, and we don't consider them to be true soil absorption fields anymore. So I just want to throw some of these technologies out there to you. If you hear of them, you can know in the back of your mind, oh, this isn't up to par. So up in the upper left, we have a buried sand filter. These were really popular in my area, my hometown, home county, where we have really, really tight clays. And the water just doesn't percolate water, or the soil doesn't percolate water very rapidly. So we would rely on these buried sand filters, not we as in me, but a lot of folks in the past have relied on these. Essentially, there's a hole dug in the ground. We put some aggregate, some pea gravel in there. They would discharge their effluent over the top of that, and then we would collect it at the bottom of it. And if you can't read that, it says to a discharge. So these were really good at filtering effluent. They did not kill all the pathogens in that effluent, and then we still discharged that to a waterway. So again, did a really good job of filtering, but not a real good job of treatment. And if left many years without maintenance, those failed, so they would come to the surface. A dry well, these are probably more prominent in your neck of the woods. Those folks that are listening from Newton and Jasper County, and up in the counties around Lake Michigan, we see lots of dry wells. Essentially, these are open, and the sewage goes in and seeps out into the water table through those open holes there. So there are still a lot of dry wells in use, and we frequently come across those when we're putting in replacement systems. Down in the lower left, we see a lagoon. If we just couldn't get rid of the water in any way, we dug a hole and we put it all in that hole and let evaporate off what would, and we were left with sludge and scum that would again seep down into our water tables and could contaminate potable water and groundwater. This is a stack feed chlorinator here in the bottom right. This would typically follow an aeration unit, which essentially was a little blower that you put into like a septic tank or a secondary tank. And then we ran the wastewater that came out of that tank over chlorine tablets. Chlorine is a really good sanitizer and can do a great job of cleaning up those pathogens. Unfortunately, chlorine needs contact time. And these were just little bitty units, and you could flush a toilet and the water, would come out of the septic tank and go through that chlorinator, and there would be absolutely no contact time. So the flow of water really prevented the water from being treated adequately. So a lot of people still see these, and a lot of people think that they work really well. In fact, we've got some people that still put chlorine tablets in theirs. What they don't understand is a lot of times those chlorine tablets will get stuck in those feeder tubes, and they think the chlorine is still there, and actually there's no chlorine down in the bottom of that, so it's really not doing much of anything. So when we come in contact with any of these, or we find out a system consists of something like that, we do have to make sure that they get their system upgraded and a system put in that's going to actually treat and disperse that effluent. Location. We talk about discharging systems, and I'm here to tell you, more often than not, I see these. This is a system that has been dye tested. A home has been dye tested, and these are discharges of wastewater. That's how we trace that. This one here, I call the silent one because this is somebody's backyard. They don't have a soil absorption field. We don't know where that wastewater is discharged. So while we can't see it on their property, we dye tested, there was no dye that came out. Their sewage is going somewhere. It doesn't just dissipate. So it may be a quarter of a mile or a mile down the road onto someone else's property. So that's really the scary situation. A discharging system is what we call a non-system. So if we have a septic tank and either a straight pipe or a discharge pipe or a tile that goes to a ditch, a culvert, pond, lake, ravine, creek, or just out on the surface of the ground, those are non-systems, and they do not qualify as an on-site sewage system. And in fact, those systems are in failure. So on-site sewage system maintenance recommendations. So hopefully we have a good idea of what is and what isn't an on-site sewage system now. So how do we maintain those systems to make sure that they have good longevity and that they last for quite some time? Well, again, this is nothing new. This is a publication, sorry about that. This is a publication from January of 1922, Sewerage and Sewage of Farm Homes. This talks about how care in operating is absolutely necessary. No installation will run itself. So even back in 1922, we were talking about proper maintenance of our septic systems. Again, in 1929, sanitation, sewage treatment for isolated houses and small institutions where municipal sewage system is not available. We have someone here shown pumping a septic tank in a little horse-drawn carriage. So again, this is nothing new. We've required maintenance of these systems to perform optimally for many, many years. So septic system maintenance, what does that consist of? Well, primarily people think of cleaning the septic tank. And I do say cleaning. It's not just pumping of the septic tank. we actually want to clean the interior of that septic tank. If we have someone there that just pumps out the liquid portion, we're doing kind of an injustice and really kind of throwing our money away, because if you recall that cross section of the septic tank, it's the sludge in the bottom and the scum at the top that are really what we don't want going out to the soil absorption field. So we need to get all of that out of the septic tank. And we actually, our good pumpers will actually clean out a septic tank. Sometimes they'll scrape the walls or put some water back in there to hydrojet that waste out and make it loose so that they can suck it up in their vacuum trucks. So that's primarily the maintenance activities that most people think of. But we also occasionally have to pump out a dosing tank if we have a dosing tank. If we have an effluent filter in the system, we need to make sure that that filter is cleaned, and we want to put that everything that's cleaned off that filter back into the septic tank. We don't want to put it out on the lawn. Sometimes those effluent filters are replaced. Want to make sure that if there's a dosing tank, that the effluent pump is still performing optimally, still working and functioning for that system. There are reasons for those pumps to be in those systems, even if they could flow by gravity. Maintenance is also checking our distribution boxes. I have a personal story here. Not last Christmas, but the Christmas before, Christmas of 2018, I had a group of my family over and heard some gurgling in my drains, and that was the first time I'd heard it. Well, upon investigation the next day, my husband and I found that our distribution box had actually deteriorated to the point where it was no longer viable, and we had to go to the health department and get a permit. I'm a licensed installer, so I actually changed out my own distribution box. I wouldn't recommend that for most people, but I am a licensed certified installer, so I was able to do that. So a lot of times those will also need maintenance. If you have a pump, you're going to have some sort of an electrical panel. Make sure that electrical is safe and in good working order so no one gets hurt with that. Walk over the soil absorption field to make sure there's no wet spots or soft spots. If a system is struggling, it's better to catch it early and make small repairs or upgrades to that system before it goes into full-blown failure. A lot of times, once you get full-blown failure, it's really hard to repair that system. It's highly likely that it'll need to be replaced. And of course, with today's technology, we have systems with all kinds of bells and whistles. So those types of systems may have other components that also need maintained at the same time. So we actually do not recommend septic tank additives as a system maintenance activity. We'd prefer you to save that money that you spend on your septic tank additives and put it into regular system maintenance. Many septic tank additives are just kind of a feel-good thing for homeowners. They feel like they're doing something proactive to take care of their system. And in fact, a lot of our septic tank additives have shown to be actually have a negative impact on a true system, a septic tank and a soil absorption field. In a lot of cases, they'll cause emulsification in the tank. The fats, oils, and greases will be emulsified and mixed with the liquids. The solids that fall at the bottom of the tank that should not be going out to the soil absorption field are put into suspension, and then everything leaves the septic tank. So at first glance, you're like, oh, I don't have to maintain my septic tank because it's all out of there. It's all been put into suspension and sent out to the soil absorption field. Well, the most important and the most expensive part of your system is the soil absorption field, and we do not want those things going out to the soil absorption field. We do want them pumped out on a regular basis. So what kind of frequency are we looking at? It really just depends, and I think I've got a slide later on here, so I'll talk about that in a minute. Again, removal of the sludge in the septic tank, and it reduces the buildup of fats, oils, and greases when we pump out that tank. It increases that system longevity. We don't want those solids and the fats, oils, and greases going out to the soil absorption field. And we also need to check mechanical components. I've got a picture here of a septic tank outlet filter. It looks pretty nasty, I understand that, but we can see that this filter is actually doing its job. It has filtered the wastewater so well that it's actually caked with stuff that would normally have been sent out to the soil absorption field. So yes, it does need maintained. This filter does need cleaned, but it is really doing its job. and here we have a garbage disposal, just know the activities in your home are going to dictate how frequently that septic tank needs to be maintained. Garbage disposals the use of garbage disposal are going to increase your maintenance frequency for your septic tank, because we have a lot of organics going out there every time we use that garbage disposal. So here we go. Septic tank cleaning, the frequencies based a lot on the water usage in the home. If you have a garbage disposal, the number of occupants versus the size of the system. If you're maxing out that system with occupants in the home, then it's going to need to be maintained more frequently. I previously had 5 people living in my home on a 3-bedroom size system. And I had my system maintained every 2 years because I knew that I was really stressing my system. Well, now that it's just my husband and I, we've moved back to every 4 years. And I know that's probably even a little bit too frequently for what we need, but that's my frequency for maintenance. Other things that you can do in your home, daycare. If you bake a lot, you're putting a lot of organics into your system, and that causes the waste strength to be higher and more TSS, more BOD in your system. Hair salons, photography development or chemical use, medications. And I know folks that take medications, it's not like you can just stop, but understand that a lot of medications, especially chemo treatments, are going to really mess up the chemistry of your septic tank. And a lot of times if you have an outlet filter, they will plug very quickly. And those systems do need more frequent maintenance. Also, we need to do our dosing tank and our pump, confirm that those are working well, as well as our soil absorption field. Some indications that your system needs to be maintained are slow drains or gurgling drains, and that's what led me to believe that my system was experiencing troubles. If you're having sewage backup, remember that is a sign of failure. So we need to take care of that really quickly. Sewer smells can often be something simple, such as a plugged vent, but if you don't get it taken care of right away, it can affect your soil absorption field and the workings of your septic tank. Soft or wet spots in the yard, again, we need to investigate those and take care of those quickly, and as soon as they come up, not wait a year or two hoping that they're going to go away. Why do systems fail? Well, there's a few reasons. A lot of times they're just installation nightmares. Now, for the majority, most of the installers that I've worked with are very knowledgeable and they're very good, but sometimes things happen. Sometimes someone inexperienced or unknowledgeable about systems in Indiana come in and put systems in, and they're just not right. The soils can be an issue. The water table can be an issue. If we can't get the site drained to provide an oxygenated zone for our systems to work, that's going to be an issue. So we see some issues here. These are large clods of dirt that have been put over a recently installed system. This soil was worked too wet. It's going to be compacted. We've got large boulders here, not boulders, but clods of dirt that could impact subsurface components. Here, it's definitely too wet to be installing the system. In the lower right, where we've got tracks from equipment that have caused compaction. So that's not a suitable site for a system. Over in the lower left, we've got all kinds of vehicular traffic. Remember, that system has to both treat effluent and move water. If we have compacted soil around that system, it's not going to move water away from that system. The water movement is going to be impeded, and that's going to impact the workings of the septic system. Lack of maintenance, hydraulic overload, too much water use. If we use our septic system as a trash can, if we put fats, oils, and greases down our septic systems, poor land use. Here you see like a go-kart track around a system, and this layer of snow or ice here really isn't snow or ice, it's frozen wastewater. This was one I investigated, so I understand that. This is a mound where we've made a motorcycle jump. Chemicals and medications. So these all fall into the category of homeowner abuse. And homeowners may not even understand that they're abusing their systems, and that's why we're trying to get the word out about proper system use and maintenance. Lack of knowledge or apathy. If you just don't understand that the water impacts your system, or that compacted soils can impact your system, as well as simple things like gutters and downspouts, direct those away from your soil absorption field. We want to get as little extraneous water into the system as possible, because that system is already taking a full load in wastewater from the home. So inspections, operation and maintenance, again, I want to recall that to your attention. That's my soapbox slide. This is why I do what I do, and hopefully this is why you care about your system and your watershed. So I'm also a member of IOPA, the Indiana On-Site Wastewater Professionals Association, and we have a certified inspector program, and we train inspectors in the state of Indiana, and it's a 3-day training to complete a comprehensive, thorough examination of each component of the on-site sewage system. And we document the components, the location, and the functionality of each and every component of the system that's inspected. And we compare that and determine if it's in compliance with the standard. Well, the standard is the rule, the Indiana rule that's in place when that system was installed. So there's no such thing as a quick inspection unless you know where the discharge is. So just because we run a dye test, that's not a full system inspection. So if we put dye down the stool and we don't see dye, that doesn't mean that that system is up to code or functioning. If we do see dye, it's definitely a problem, and most likely that system is in failure. So it can be an easy inspection with a dye test, like I said, if you know where the discharge is. So what is not part of an IOPA on-site sewage system inspection? It's not a warranty or a guarantee of future system performance or longevity. It's just to determine what components are in the system and if they're functioning properly. It's not an approval or disapproval of the on-site sewage system. That should be left up to the local health department. It's also not a home plumbing inspection, and it's not a repair of faulty or broken components unless your inspector also offers those services. So here's the dye test. Positive is always positive. So if we see dye after we put dye through the system, that is tracing the sewage, and so we know we have sewage on the ground or in the discharge, wherever it is. Negative is not always negative. It's really inconclusive. If we run a dye test, like I said, that's not evidence that that system is either up to code nor functioning properly. Maybe we just don't know where the outlet is. Maybe we're dealing with a sand filter and the sand just didn't allow the dye to pass through. Maybe there was no water use or too much bleach use in the home. Maybe the homeowner pumped the tank, thought he was going to bypass the dye test by pumping that out of the tank. Those things happen. So that's why it's not always just conclusive to run a dye test on a system. Why inspection and why now? Well, we have a lot of federal and state mortgage loan programs that are requiring inspections. Real estate transactions, we have a few counties in the state of Indiana that require system inspections prior to a real estate transaction, and that's to protect the buyer as well as to protect public health. Our rule requires inspection for troubleshooting for the use of best judgment. If we're going to put a replacement system in and it can't quite meet the rule requirements, the local health departments have the authority to use best judgment in the replacement of that system, but the system has to be inspected first. Also, we have some statutes that allow exemptions from connection to sewer. So if there's going to be a sewer extension from either from a not-for-profit utility, a municipal utility, or a regional district, and a homeowner wants to be exempt from that sewer connection, they have to have their system inspected and shown that it consists of both a septic tank and a soil absorption field that has not failed. So those are the reasons why most people do it. There are others. Home buyers are becoming more and more savvy. They want to understand that what they're purchasing is in good working order and meets the rule requirements, and they don't want to be hit with that $10,000, $20,000 bill shortly after they move into the home and realize that their septic system is no longer functioning well. So it is becoming more and more of a trend, if you will. Plus, we have to realize that we've had legislation introduced in the state of Indiana the last couple of years that could possibly require more real estate transaction inspections in the future. It has not passed yet, but I don't think it's gone away for good. The IOPA inspection form is lengthy. It's essentially a fill in the blank and check mark type form. It is 10 pages long, and most people complain about that. 3 of the pages are for demographics, like where is the home at that you're inspecting the system? What does the system consist of? 1 page is just for water test results. So it's really not that long. It is very comprehensive. IOPA certified inspectors have to use that form if they're doing an IOPA certified inspection. We train from that document. And again, the key to the inspection is to document everything about the system. Something that's not documented in writing or in pictures essentially didn't happen, and we don't have the information that we need to make those decisions. We also have an inspection summary report. It's a single-page document. This is more understandable for the homeowner, for the realtors, for the bank. It essentially goes through things like when was the system installed, what components are there, is it in failure, does it meet that definition of failure, or does it need, some sort of upgrading. So these are some of the things that we see. Here is a gentleman in the upper left pumping a septic tank. On the right side, we see a sludge measuring device where they're determining how much sludge and scum is in the tank. And this can lead us to interpret how often that system has received maintenance. In the lower left is a distribution box that's been opened, obviously has some corrosion. It looks like mine in my yard almost, but it's not. Where we see most of that concrete is gone from around those outlets. Can cause problems, definite problems. We can get some groundwater infiltration and exfiltration there. Again, we can look at background. This is an aerial view here on the left showing just from a county GIS website where we have some leakage of the system. And the line there where that leakage kind of stops is a perimeter drain. So if we're training the inspectors to look at these kinds of things and make the determination, well, I'm going to take a water sample at the drain outlet because it's likely that we're getting sewage carryover from the soil absorption field. Again, here we have a picture of a soil absorption field on the right with a subsurface drainage and a little puddle there. That's sewage water, and that's the perimeter drain, and that's why the perimeter drain, the grass over the perimeter drain is very green, because it's getting all of those nutrients from the sewage, and that sewage water is just being carried to wherever that drainage outlets. Again, we have discharge concerns. This is a picture. If we have that concern, we definitely want to get, note where that's at and take a picture of it. Again, just some more things of what we typically see when we do inspections. Another distribution box that has problems. Here's a distribution box that's being pumped to, doesn't have a sanitary tee or a baffle. This is on the left is a newly installed system. That's why there's no grass growing there yet. Some discharge concerns here. Always want to take note of those so that we can prove that system was having some trouble. Interpreting the IOPA inspection report, we don't imagine, or we don't presume that the typical homeowner can evaluate or interpret everything on that inspection form. So we do ask that the inspector indicate if that system is exhibiting signs of failure, does it meet the rule and effect at the time of the installation, or does it not meet the rule and effect at the time of the installation? Are there any repairs needed, or is further investigation needed? So these are some things that the homeowner can look at and can interpret. I mean, they're pretty straightforward there, so that both the buyer and the seller can interpret that the same way. Minimally required, again, is the septic tank and the soil absorption field. So if you're looking at an inspection report and it doesn't comment on both of those, then there's going to be a problem with that system. Failure is a health hazard and abatement is required. Again, there's the definition of failure as described in the rule. We also have a portion of the rule that deals with components that are defective, malfunctioning, or in need of service. If the system is not truly in failure, doesn't meet the definition of failure, like in the upper right corner is a distribution box. I believe that is mine at my home. It's pretty much gone. There's not much there. There's no system failure there, but boy, does that component need replaced or repaired. In that case, it's going to have to be replaced. We have in the lower right corner, we have a pump tank, and there's no pump there. That's a pump pedestal that you see. So definitely needs repaired or replaced. And in the bottom picture, that's a broken off observation port for the sanitary, or excuse me, for the residential sewer that's been broken off. So we're allowing groundwater and precipitation to get in there. So those are the kinds of things that the local health department can still require to be repaired, replaced, or serviced, even if that system is not in failure. So review the completed report thoroughly, review the summary report, and I've got highlighted here or bolded, ask the local or state health department for interpretation. You can also ask the inspector for the interpretation, but definitely don't go to your realtor and say, what does this mean? Because the realtor or the banker or a home inspector may not know how to adequately interpret that report. So your local health department is always the number one to go to. They should be able to help you interpret that report, let you know if that system is going to need any repairs or be replaced. And us at the state health department, we're always available as well for a second opinion. So I always, some of the IOPA inspectors are concerned because they're having trouble selling the IOPA inspection, because it is a very thorough inspection. It is a very lengthy inspection. It does require pumping of a septic tank. There are other types of inspections that can be bought. This indicates a drive-by inspection. I've seen many of them where someone walks over the yard and says, oh yeah, everything's working fine, your system's good to go. Or they flush your toilet and the toilet flushes and the water goes away. And they say your system's good to go, no problems there. Well, those are not inspections. So my theory is that you do get what you pay for. And you also have to understand if an IOPA certified inspection is required. So if a certified inspection is required, then hopefully you will make sure that you have the IOPA certification or certified individual there on the site to do that. You also have to understand what is the quality of the report that you want. Do you want a fully written report? Do you want it very thorough? Do you want every system component inspected? So we don't want the drive-by inspection. Obviously, they're going to be much cheaper. But some questions that you need to ask yourself about the inspection, or maybe ask of the inspector that you're planning on hiring is the septic tank going to be pumped and inspected? To fully inspect a septic tank, it has to be pumped. We have to look into that entire tank to make sure it's watertight. Has the distribution box been opened, or will it be opened as part of the inspection? Because that's very, very critical to those systems that have distribution box, to open that up to make sure we're getting equal flow and that the box is still in good order. Is every component looked at, not just the septic tank? We don't want to flush just the toilet and say everything's good to go. The septic tank accepted it. We want to make sure that there's a soil absorption field there. Has a background search been completed? With IOPA certified inspectors, they're trained to go to the local health department to pull the actual permit or the installation, look for any complaints, look for any modifications to the system, so they know what should be in the ground and if it was approved by the local health department at the time of installation. And has the system been compared to the standard in place when the system was installed? We spent a great deal of time going over the history of on-site sewage disposal in Indiana with these inspectors so that they understand what standard they're comparing the system to. A system installed in 1992 is not going to meet the requirements of today's rule. So it has to be compared to the rule that was in effect in 1992. So the last one is the report written and detailed? I've seen many, many inspection reports completed on an invoice that's provided to the homeowner. And literally all it'll say is system okay. Well, that doesn't give me any details. That doesn't tell me what you've looked at, what you've inspected. Is it compliant with the rule? A system that consists of a septic tank and a discharge tile can be working. but that doesn't mean that it's up to code or working properly. Yes, the toilet flushes, but it also discharges into someone else's backyard. So there's my contact information. I'm not going to go over the additional resources. I think Derek's going to do that, and I've probably used way more time. I know we've had some technical difficulties, so I'm going to stop sharing my screen and give it back to whoever needs to have it.
I can take over from here, Alice. Thank you so much for all that useful information. Derek is still having technical difficulties with signing on, so I will take it from here. While I talk about additional resources that are available to you guys, if you could please go back to Slido. Once again, that's SLIDO, and just complete the post-workshop survey. There's 6 questions. It'll just take you a minute. I will continue to talk about the additional resources. So you should have received in the mail a packet of additional EPA resources for septic maintenance. Now, that is only a fraction, not even 1% of the amount of information that the EPA has available on their website concerning septic system maintenance. So I really encourage you, if you have more questions, to please visit the EPA's website and look up their additional resources. Really quickly, I wanted to thank our sponsors, our t-shirt sponsors, which will be coming to you in the mail to your RSVP address for those who attended, the first 25 people. Pelsy Septic and Drain Cleaning in Francesville was our t-shirt sponsor, so we thank them very much for that. The Jasper County Soil and Water Conservation District, the Newton County Soil and Water Conservation District, the Indiana State Department of Health, which is with Alice, and also the Lower Kankakee Watershed Initiative for sponsoring this workshop. This webinar was recorded, so it will be available on the Jasper County Soil and Water Conservation District's YouTube channel within the next couple days, and we will also share it on social media. Let me check in here on our Slido. It seems that everybody has participated in the Slido. So if anybody has any questions about this webinar today, feel free to reach out to us. It's Jasper County Soil and Water at gmail.com, or you can also call us at 219-866-8008 extension 3, and we will direct your question to the correct person, whether it be Alice or Bree over at the Newton SWCD. So on behalf of all of the speakers today and all of the sponsors, I thank you for joining us. There is one question that it was asked and Alice answered it, about if an outlet filter can be added onto a system that doesn't already have one. Alice said, yes, an outlet filter can be added to an existing septic tank to prevent solids from going to the soil absorption field. So there you have it. And if you have any more questions, feel free to send us an email. And thank you so much for joining us today. Have a good one.